Hello everyone, welcome to Eduxcite classes. My name is Monit and in today's session we will discuss the circular motion continuing from my previous video. If you are new to this channel, please check my playlist. I have solved from the topic wise from A.1 kinematics. You can check the playlist, the link is given in the description below. Okay. Also you can download the PDF of this video available on my website. The link for the website is also available. Check the description below. Okay. And if you have any doubt related to any of the questions that we will be discussing in this particular video, you can message me on my WhatsApp number. You can scan the QR code, or if you want one-to-one tutorial sessions with me, please chat at the appropriate times. Okay. So one more request, like please share this video with your friends, classmates, so that it reaches to the masses and they also get benefited from the video. Okay. So let us start. Before that, we should know these are the formulas, the basic formulas which are provided in your data booklet. You should be aware that what are the formulas given and how to use your data booklet efficiently. Okay. So the acceleration, the centripetal acceleration formula in different forms, as well as the linear speed and in terms of relation with the angular velocity. Okay. So this all information is provided in your data booklet. And this is the one most misconception among the students, that centripetal force is not a different type of force like tension, friction, weight. These all are the different types of forces, whereas centripetal force is not a type of force. It's generally a way of describing the results of a force. So whatever the net force which is acting towards the center, that we will consider as a centripetal force. It is not another type of force. It is just the net force acting towards the center if an object is moving in a circular motion. Okay. So we will solve questions related to that also. And centripetal force should not be labeled in any of your free body diagram, because in force body diagram or free body diagram, or in short we called FBD, we always draw the forces, but centripetal force is not a force. We are not supposed to indicate that. Only the force which is responsible for making that object moving in a circular motion, that you are supposed to draw. Okay. So I hope I have cleared this misconception. So I will give you time to pause the video and you can solve with me as well, or even you can download the PDF. Okay. So pause the video for question number 1 and solve. Okay, now here we have to find out the maximum speed. So always remember, whenever an object is turning, it will make a circular motion. It will be a part of a circular motion, right? So in this case, whenever a car is turning, right, so the friction of the tires will be in this direction, and this will be the arc, and this friction will be your centripetal force. So for solving A part, can I say that the centripetal force is the nothing but the friction, and the friction will be, we know the formula, which is mv square by r, right? Now the information about the coefficient of friction is given. Now we know that friction, we have discussed this, is nu times n, and n is nothing but weight, which is mg in this case, right? So can I say nu mg is equals to mv square by r, because friction is responsible for the centripetal force in this case. Therefore m and m gets cancelled. So from here v square is nu g times r, or v is under root of nu g r. Now you just have to put up the values. Nu is 0.7, g is 9.8, r is 95 meter. So when you put up the values, you will get the answer. I have already done the calculation. The answer will be something near about 26 meter per second, right? So I hope the A part is quite clear. So make sure that whatever the force is acting towards the center, that will be considered as your centripetal force. Equate that force with respect to mv square by r and solve as per the requirement. Now in the B part, in wet condition, the coefficient of friction is reduced to 0.4. When there is a rainy season or whenever the road is wet, the friction reduces to 0.4. Predict the safe maximum speed now. Now what should be the maximum? Now if you see here, if you look at this expression, So it is irrespective of the masses, so it is only depending upon g and r are constant. So nu is 0. Now just put up the values. So we know that v is equals to nu g r, and this time nu is 0.4, g is 9.8, and r is 95. So you can see now the speed has decreases, and I have done the calculation. It is near about 20 meter per second. Okay, so this will be the answer for A part, and this will be the answer for B part. And that is why you might have seen that whenever there is a rainy season, we have to lower down our speed during the turning, otherwise your vehicle may get skid. Okay, so these are the answer for the part A and B. If you have any doubt, just comment below. Now pause the video for question number 2 and solve. Okay, in this case, a mass of 1 kg is tied to a string and it is moving on a table, on a frictionless table, right? The length of the string is given as 40 centimeter and the speed is, revolution of speed is 2 meter per, that is V is given. Calculate the tension in the string. Now we know that if this is moving in a circular motion, the tension, if I am considering this as an object, the tension will be in this direction, right? So the tension here, if I want to solve A part, so my tension will be nothing but the centripetal force, which is mv square by r. So just put up the values now. So tension, mass is 1, speed is given to you 2 square, and radius is 0.4. Keep this radius in meters, 0.4 meter, right? So when you solve this, you will get the answer simply as this will be 4, this will be 10 Newton, right? So the answer for A part will be 10 Newton, quite easy. Now the B part, the string breaks when the tension exceeds 20 Newton. Determine the largest speed at which the mass can rotate. Now we have to find out the largest speed at which this mass can rotate, and the condition is the tension will be 20 Newton if it exceeds. So I just put up the value of tension 20, mass is 1, V square I have to find out, and R remains the same, 0.4. So if this will be equals to 20 into 4, this will be 8 equals to V square, and V will be under root 8. So V comes out to be something around 2.83 meter per second. So I hope it is quite clear how to solve these type of problem. Now simply the C part, if you look, the breaking tension of the string is 20 Newton, but you want mass to rotate at 4 meter per second. Determine the shortest length of the string that can be used. Now I want, the breaking tension is again the same 20 Newton, that is not changing, but I want the mass to rotate at 4 meters. So I can shorten the length of the strings. What should be the shortest length possible? Now if I want to solve, again I will be using the tension. So this will be the radius, the length will nothing but the radius only. Okay, length of the string will be your radius. Okay, so I can write this as L if you want. So L will be mv square by tension, maximum that can be sustained for the length, should for the minimum shortest length. So mass is 1, we have to keep it 4, tension is 20. So this is 16 by 20. So this will be nothing but L minimum will be 0.8 meters or 80 centimeters. Okay, so this is the way you can solve. Determine the shortest length of the string that can be used, which will be 80 centimeter for the string to rotate at a speed of 4 meter per second. So this is question number 2. I hope I have tried my best to discuss. If you have any doubt, just comment below. Now pause the video for question number 3 and solve. You can do it. Okay, now the lift force is acting in this direction and the plane is inclined at an angle of theta with the horizontal. We have to find out the radius of the circle with it will make. Okay, So what I can do is I can just draw a parallel line. So this will be theta, so this will be 90 minus theta. Now if I want to make a component, because if it is moving in a circular motion, this force will act as a centripetal force, right? So if this force is acting as a centripetal force, can I say that this will be L cos of 90 minus theta, because this is the component. If you have not understood how I made this L cos of 90 minus theta, this will be equals to L sin theta. L is the lift force, 90 minus theta is sin theta. Okay, so this will be L sin theta. Similarly, perpendicular component of the lift force, so this will be L sine of 90 minus theta will be L cos theta, right? So I can directly write this as L cos of theta. Now if you have any doubt about how this is L sin theta, L cos theta, and how to make the component, please watch my previous videos of A.1 of the forces and all those, where in the parabola also parabolic motion also I have discussed this. So you can check my videos if you have not understood. Okay, so this is the L sin theta. So can I say here my L sin theta will be mv square by r, right? And L cos theta will be nothing but the weight. So this will be weight. Okay, so let us say this is my equation 1, this is my equation 2. Now I am dividing equation 1 by 2. So I can say L and L gets cancelled. Sine over cos is my tan theta is equals to mv square by r divided by m into g. M and m gets cancelled. So this is v square upon r into g, right? And I have to find out the r. So r will be v square upon g times of tan theta, right? Now v is given to us as 180, so I am just putting up the value as 180 square divided by 9.8 into tan of angle is 35. Now if you put up these values in your calculator, you will get the radius of the circular motion. I have already done the calculation. It will be something around 4.7 kilometers. Like, it will give you answer in meters that you can convert it into 4.7 kilometer, or you can give the answer in like 4.7 into 10 raised to power 3 meter after rounding off into 2SF. Okay, you can do the calculation. If you have any doubt, just comment below. I hope it is quite clear. Now try question number 4. Pause the video and solve. You can never give up, guys. Just try it. You can do it. Okay. Now free body diagram of the force of the girl. So I can simply say that let us consider this as the point mass. So vertically downward is mg, upward will be friction, right? Because it is not moving down. So, and it is in contact with the surface, so there will be a perpendicular force, that will be normal. So this will be the free body diagram. I hope it is quite easy and clear. Now determine, this is quite important, and determine the minimum number of revolutions per minute for the girl so that she does not slip down the wall. It has to rotate at a particular revolution at a particular speed, you can say, in order to support the weight, and the friction will balance so that it will continue to be in the same position. Now for that, what I can say is, I can write down two equations from my free body diagram, that friction is equals to mg, or nu n is equals to mg this time, and another one I can say the normal force is equals to the centripetal force, that is mv square by r. Now using these equation, can I say minimum number of revolution per minute for which the girl does not slip. So I can find out instead of mv square by r, I can use m omega square r. So this will be m omega square r. right? So first let us find out the normal is m omega square r. So what we can do is we can equate these equation. So I can put nu times m omega square r is equals to mg. M and m gets cancelled, so I got omega square as g by nu times r. So if you solve for this, omega will be under root of g nu times r. So if you solve this, 9.8 upon friction, coefficient of friction is 0.6 times r is 5. So if you solve this, you will get 9.8 divided by 0.6 divided by 0.5 under this will be 1.8. So we know that omega is 2 pi f. So 1.80739 is equals to 2 pi f. So f will be this divided by 2 divided by shift pi. So frequency comes out to be 0.287. Okay, so this will be revolution per second or per minute if I want to do, because the question is asking revolution per minute. So into 60 will be 17.25. So I can say the revolution per minute is, I just multiply this with 60, okay, because it is per second, we have to give it per minute. So this is rounding off, it is coming as 17 revolution per minute. So this is the answer for your question number 4. I hope it is quite clear. If you have any doubt, just let me know, comment below, or you can WhatsApp me as well. Now train your mind to solve question number 5. Pause the video and solve. Okay, so here we have to determine the tension in each string. So let us say this is tension Tu, this is the upper string, and this is the tension TL, which is the lower string. So first of all, I will find out the angle. This angle and this angle will be same because it is quite symmetry. So if this hypotenuse is 1, perpendicular is 0.5. So using the trigonometry ratio, sine of, let us say this is theta, is 0.5 by 1, and theta will be 0.5 is half. So sin theta half is 30. So this is 30 degree. Okay, so first you have to find out the angle. Now what we will do is, this ball is revolving in a circular motion, and we know that this will be the radius of the horizontal circle in which the ball is moving. So using the Pythagoras, you can easily find out the length of this. This comes out to be, let us say, I have already done the calculation, this will be 0.866 meter. This is nothing but 1 square minus 0.5 square under root. That will give you the radius, I can say. Okay, so this will be 0.866. Now we know that what we can do is, if I want to resolve, this will be Tu sin theta, mg will be in the downward direction, plus TL sin theta, and this will be Tu cos theta plus TL sin cos theta, right? So this will be don't look at the arrows, it will be quite equal. Okay, so this will be the downward force, weight is acting in the downward direction, and the component of the lower tension, this is theta, so this will be TL sin theta, lower tension sin theta component. So they both are in the same direction, so they will get added. Tu is in the upward direction, though it will be Tu sin theta alone, and towards the center, both component of the tension in the horizontal is coming in this direction. So we have to determine the tension in each string. So I can make out the equation for horizontal. So for horizontal, I can say Tu plus TL times of cos of 30 is equals to mv square by r, because that is the centripetal force for this. So we know m, we know v, we know r is this, r is 0.866 now. So please do not forget this. R we know, V we know, M we know. So we can find out Tu plus TL. So if I simplify and putting up the values, Tu plus TL, I have already done the calculation, is coming out to be 21.34. Similarly, if I want, so remember this equation. Similarly for vertical I can say Tu sine theta is equals to mg plus TL sine of theta, right? So this will be Tu minus TL times sine of 30 will be equals to m times g. M and g we already know. So when you put up the values for this, you will get Tu minus TL is equals to 4.9. Now this is my second equation. So using equation 1 and 2, you can say, let us say this is equation 1, this is equation 2. So you can say using equation 1 and 2, Tu, the upper tension will come out to be 13.1 Newton and the tension in the lower string comes out to be 8.2 Newton. You just put up the values in your calculator, you will get your answer for question number 5. So just you have to read the question carefully, and first and the foremost, whatever the variables are not known, if the dimensions are given, you can find out the angle, and whatever the force is acting towards the center, just equate this with the centripetal force, that is mv square by r or m omega square r, and accordingly solve the equation, make out the equation, you can easily solve. So that is quite easy. So you can make it happen for question number 6 now. Pause the video and solve. Okay, so now in the A part, calculate the magnitude of the centripetal force acting on the coin. We know that centripetal force A is mv square by r. This is my centripetal force. Now we know the m, we know r is in centimeters, so I can say r is 0.17 meter and mass is 10 raised to power minus 2 kg, right? Converting into kg. Now, but we have to find out V. So for V, I can say the one information is 13 revolution per minute. So V is what? Total distance over total time. So total distance is 34 times of 2 pi r, that is 0.17. So this is the total distance in 1 minute divided by 60. So this, if you solve, you will get V as 0.6 meter per second. Now we know the V also, so putting up the values for the centripetal force, 10 raised to power minus 2 times 0.6 square divided by 0.17. So you will get the centripetal force, I have already done the calculation, 0.022 Newton. So this will be your answer for the A part, which is quite easy, right? Now for the B part, read the question. Now the friction provides this force. Now this force, centripetal force, is nothing but the friction. Now the turntable speed is increased so that more friction is required to keep the coin in the same place. If the coefficient of friction is 0.43, what is the greatest possible value for the frictional force between the turntable and the coin, right? So we have to find out the maximum frictional force possible for this 0.43. Now I can equate this with the equation of friction as nu as into n, right? So this will be nothing but nu as is given 0.043. Now n is nothing but m into g. So m is 10 raised to power minus 2 into g is 9.8, right? Now this force comes out to be 0.042 Newton. That is the answer for the B part. Okay, quite easy. Now determine the maximum angular velocity of the coin which will enable it to stay in the same place. Now maximum angular velocity, I can say F is equals to m omega square r. Now omega, angular velocity is omega, so omega square is F upon m into r, or omega can be written as under root of F by m into r. Now F is 0.042, we already calculated. M is 10 raised to the power minus 2, r is 0.17. Under root of this, if you solve for this, the angular velocity will be something around 5 radian per second. The unit for angular velocity is radian per second. I hope you know this, right? So now for D, it will be unchanged. The reason being, if you look at the equation here, the friction is nu as into n equals to m omega square r, right? So when you add, n is what? N is mg. So m gets double, so this also gets double. So this and this will get cancelled out. So there will be no change. So you can say as weight double, the friction also double. So there is no net change in the angular velocity. Okay. Now this is the question for HL students only, right? Why? The reason being, this is a vertical motion, and that too only the top and the bottom parts are required for you to understand. The in between parts are not required. So read out the question carefully and try to solve this. Pause the video and solve. Okay, so you can say it will break at the lowest point. The reason being, if you look at the condition, what will happen at the lowest point? The string will be like this. So mg is acting in this direction, tension is acting in this direction. If I want to make an equation, I can say what will be is like it will be mg minus t, okay, is equals to mv square by r. So sorry, it will be T minus mg, because tension is here, it is moving in a circular, so always the force towards the center will be greater. So T minus mg is equals to mv square. So T will be mv square by r plus mg, and this will be the maximum value of the tension. It is the maximum value. So when it will be maximum value, then there are more chances that the string may break as compared to any other position. Now if you read out the part B, this is quite important to understand the minimum speed. Now minimum speed of the point of the stone will be when the at the highest point, when it will be at this position, it will have the minimum speed. So we have to find out the minimum speed for which it is at the highest point, and it will be taught. So here the highest point for B, first I can say at maximum, at highest point I can say the tension will be minimum, or I can consider for minimum speed it can be 0. It can be considered 0 for minimum speed. Okay, so if this is the case, then I can say at the top only force is acting as mg is acting in the downward direction. So mg plus t is equals to mv square by r. Now t is 0, so I can say mg is equals to mv square by r for minimum. M and m gets cancelled, so v square is equals to gr, or v is equals to under root of g times r, which is under root of 9.8 times r. R is given to us as 0.8 meters. Now if you solve for this, I have already done the calculation. V minimum comes out to be 2.8 meter per second. I hope you can do the calculation on your own. So this will be your answer for the B first part. Okay. Similarly, for second, at lowest point, I have already made the equation. At lowest point, it will be T minus mg equals to mv square by r, because this will be the case. Here it will be like this. So mg is acting in the downward, T is here. So T minus mg, this will be the net force acting towards the center, which is mv square by r. Okay, so if you solve for this, so T for lowest point, we can say, and the maximum tension is given already in the question, so I can say this will be 10 minus m is how much, 0.25 times 9.8, right, into r is 0.8 divided by m, which is 0.25 under root, this will be your v. So you can do this. If you have not understood this step, let me break it down for you. So I want to find out v, so this will be the maximum speed. For maximum speed will be at the speed will be maximum, so you can say this will be T minus mg times r divided by m is equals to v square. So under root of this will be your v. Okay, so I just put up the values. When you put up the values, you will get v maximum something around 4.9 meter per second. So this will be your answer for question number 7b, second part. So I hope this is, if you have not understood, just go through it once again. Even then, you can just comment below or you can message me on my WhatsApp. Now moving on to the paper 1 type question, that is your MCQ section A. Just pause the video and solve question number 1. Okay, this is quite easy, guys. We know that V is equals to what? Omega into R, right? This equation we already know. Now, if both the points are on the same disk, they both have the common angular velocity, right? But linear speed will be different. So omega is constant. So let us say for at point P, V is omega R. At point Q, V dash will be omega times 2R. So this will be 2V. So option A and B are incorrect. Similarly, acceleration is omega square R. So at point P, if this is at point P, so at Q, A dash will be omega square into 2R. So this will be 2 times of A. So option C is the right answer, right? Now pause the video and solve question number 2. Okay, so we know that in a circular motion, the velocity is always tangential and acceleration is towards the center. So just check, this is quite easy. So option C is the right answer, right? Now pause the video for question number 3 and solve. Yeah, we have already discussed. Here the centripetal force that causes the car to go round a bend in the road will be nothing but the friction between the tires and the road. Okay. Now pause the video for question number 4 and pause the video for question number 4 and solve. Yeah, I told you whenever we are supposed to draw the forces, we never draw the centripetal force. And the only force which is acting towards the center is the friction, right? So you can say in this case, this will be the answer because these two forces are not required. There is no forces acting like this and there is no forces acting outward. It is the only force acting towards the center, and that is the friction in this case. So option D will be the right answer. I told you in the introductory part, we never draw the centripetal force because it's not a type of force, and in the free body diagram we only draw the different types of forces acting on the object. So here only friction is acting, which is responsible for making the object moving in a circular motion. So I hope I have tried to clear all your doubts related to the circular motion. Even though if you have any doubt related to any of the question, just comment below. You can even download the PDF of this video. The link is given in the description. And guys, it's a small request to please share this video as much as you can. so that it reaches to the masses. It will help all the students worldwide, whosoever is watching, and you can share with them. So keep learning with me. See you in the next video. Take care. Bye bye.